Okay, this podcast I'm going to do is dealing with Section 8.7, our book on arc length and circumference. What I'm going to do here is kind of show you guys where actually pi comes from. We use pi a lot in this section, and it's not some magical number that was passed down by the math gods or anything. It's actually the definition of pi. It's the circumference divided by the diameter of a circle. And this is one way to actually zero in on the value of pi, the 3.14159 blah blah number. Okay, what we do is we take this circle and we mess with inscribed and circumscribed polygons. Fancy way of saying, okay, I'm going to take this same polygon on the inside and the outside, and what I'm going to look at is the perimeters of these objects, because the circumference is just a fancy name for the perimeter of a circle. And if I take the perimeter of this inside square and divide it by its whatever you want to call it, pseudo diameter, and I do the same thing for the outside square, I'm going to be able to sandwich in the value of pi in between the two. So what I did here, if you look over here on the right side here, I just measured the circumference because Sketchpad can measure a bunch of stuff here. I measured the circumference of my circle here, but what I did, I cut that in half and I divided it by the radius. So if I cut the top and the bottom of the circumference of a diameter by half, I'm essentially not changing the value at all. So here I get that 3.14159. Okay, now these numbers here, this set on the left side, this is the length of one of the sides of the inside square. On the right side here, this is the length of one of the sides on the outside square. And this AB is the radius of the circle, which I'm going to use to figure out my approximations for pi with the inside square and the outside square. What I did, this thing right here, this 2 times the measure of BB triple prime here, that's half the perimeter of this inside square. So if I take half the perimeter divided by the circle's radius, I get a lower approximation for pi, which I got 2.828. Did the same thing for my outside square. Half the perimeter divided by AB here is exactly 4. So what this tells me with a square is my pi has to be somewhere in between 2.828 and 4. Okay, now how do you get a better approximation? Well, the way you do is you add more sides. So I did here, instead of a square, I did an octagon. And if you look, the octagon, it better approximates a circle than the square. Because here I got a whole bunch of open area. Here that open area is a little bit less. And I did the same exact thing. I found half the perimeter of the inside octagon and divided it by AB, which was 3.06, etc. blah blah. And same thing, half the perimeter of the outside octagon divided by that AB here, that's 3.31. So right now, it's a better approximation. I know pi is somewhere in between 3.06 and 3.31. And what we keep doing is we keep adding more sides. The more sides we add, the better approximation we get. So here I did a 12-sided polygon. And if you look by the looks of the figure here, it's getting closer and closer. It's getting sandwiched closer to the circle here. So again here, the one on the left, half my perimeter of the inside polygon divided by this radius here is 3.105. Same thing for the outside one. The half the perimeter of the outside one divided by AB is 3.215. So again, this tells me that pi is somewhere in between 3.105 and 3.215. And then you keep going and going and going. The last one I decided to do, because it's kind of hard to see on Sketchpad here, I did a 24-sided polygon, and you can barely even tell what I've done here. If I make this circle a lot bigger, I'll try to see if that will make any difference here. I'll move this. You'll be able to see the polygons a little bit better if I make this bigger. I'm making her bigger and bigger. You can kind of see here there's a little bit of space in between. But I'm going to go back to what my circle was before. Okay, now if you look here, here's how we settle on the digits of pi. Because this thing on the left side is my approximation using the inside polygon. The one on the right's my outside polygon. If you look, both of them have 3.1s in them. This one's 3.13 and this one's 3.159. So what that tells me, pi has to have the first two digits of 3.1. And what ends up happening if we add more and more and more and more sides, it's better if you do this algebraically than geometrically. I just figured it'd be easier for you guys to see geometrically. But if you keep adding more sides, what ends up happening is these digits, as we go from left to right, will settle in on a value. So like eventually, if we add more sides, the lower bound one here will be 3.14 something, and this will probably be 3.14 something. And as we add more sides, every single digit of pi gets settled in on. So you'll get like 3.141592653, blah 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 blah. Okay, hopefully that random rambling made some sense, but that's kind of where pi comes from. So again, it's not some magical number that's handed down by the math gods.